50% or more. Love Jeremy.
Geico's had this tagline for years, because we help save people money.
So wait, you're saying Jeremy copied you? Yeah, that actually does sound like something the J-Man would do.
Geico. 15 minutes could save you 15% or more.
This is Ice T,
Stone Cold Steve Austin, and
Matty Ice.
this is a cold call.
I convinced NFL teams to turn to cold water washing with Tide.
Hey Vedant, can you hear me now?
Uniforms get dirty. Tide can handle it, even in
We're
cold
gonna see if this
weather.
delay is a little smaller now.
Can save up to $150 on their energy bill.
Looks like you just made the team, rookie. Turn to cold with Tide, and that's the bottom line.
it's got to be Tide. Energy savings based on average usage across most locations.
Cool. Yeah, so it looks like the delay is a little slower. Um, I'm not sure if I can make that much better yet, but I'll try to figure that out later. Did you send me some more questions? I think I only still see the same two. Okay, yeah, just send them to me. By the way, before I forget, in the bottom right hand corner of the stream, you may want to I think there's like a notification or a subscribe button, just so if I start another live, it should send you a notification. Um, don't know where that would be. Do you see like a button to say like um, subscribe or notify? You might even have to do it on the channel. Yeah, I'll put the link in the chat just in case. So there's the link to the channel. Cool. Yeah. So if for some reason I need to end the live and I make another one, it should notify you and tell you. All right, so I think I see another question. So it looks like it's kind of the same situation, but now they're giving you like masses and different period numbers. So let me go ahead and import that into my screen so we can take a look. All right, so I'm going to import that in. Let's make that a little bigger. All right, there we go. So let's take a look. So it says a student is asked to perform experiment 1, but with a spring of an unknown spring constant. So you don't know K this time. The student performs 4 trials of the experiment with blocks of different mass and collects the data that are shown in the table. How should the student graphically analyze the data in order to determine the spring constant of the spring? So it says you can create a graph with the period of oscillation. I see. Okay, so normally you want to make a graph that will make it linear. Like that's kind of the goal. So let's see if we can make some kind of relationship here. So a second ago, I told you that the period is related by this equation, right? T equals 2 pi square root of m over k. So I'm going to kind of bring that formula down and put it here. So T is equal to 2 pi square root of m over k. And so what we can do is we can solve for k, is you would have to square both sides. So you would get period squared equals 4 pi squared, and then m over k. Now we can multiply both sides by k to get rid of our fraction. So we'll have k times the period squared is equal to 4 pi squared m. And now you want to divide both sides by the period squared, because I'm trying to solve for the spring constant. This way the period squared will go away. So we get the spring constant is equal to, and I'm going to write this a little funny. I'm going to write it as 4 pi squared m, but then it's times 1 divided by the period squared. Right. So this is one option. If you go to the channel, it should show all the videos saved. I can give you a link to the videos, but it saves them. So they're under my channel though. So let's see which answer choice kind of matches this. So the first one says, create a graph with a period of oscillation plotted on the vertical axis. Okay, so that's a problem. You don't just want the period, right? That's wrong. Because if you look at it, if you use this relationship, it's the period squared. Right? So it would have to be the period squared on the vertical axis. If you use the original relationship up here, then it would have to be the square root, right? And you have options. You can either graph the first relationship or the second one. Either one is fine. But let's see if there's an answer choice that kind of matches what we're thinking. So B says, create a graph with the period of oscillation plotted on the vertical axis and the square root of the mass of the block plotted on the horizontal axis. C said that one says square root. Right, that's what we need. Right, because if you look right there, we have the square root of the mass. Like that's present in my original relationship. C says plot period on the y-axis, but then it says plot the square of the mass. That's wrong. We don't have the mass squared. It's the square root of the mass. And then D says the student can only mathematically analyze the data by applying the appropriate equation. That doesn't even make sense. So we should have knocked out D right away. Right? But the whole point is we're either looking to graph, here are our two options, I'll just write them out. So you could have graphed period squared on the y-axis, and then graph m on the x-axis. That was one option. Or you could graph the period on the y-axis and the square root of m on the x-axis. Those were your two options. So they went with the second option, which is the original equation, like way up here. Hopefully that kind of makes sense. So answer choice B is the best answer. But it was all based on the equation for period of a spring. Any other questions on this problem? You would go to the channel. So I'll pull up the channel for you. Here we go. All right, so if you go to the channel here, right, so it's basically the channel's main page, and then go to videos, which I think I already linked for you. You should see one that says, I guess it's this one. Here we go. So this is a link directly to the last video, to the one that I stopped streaming a second ago. So it's that one. But everything's always under videos. You'll find them there. And then what I'll do later is I'll add timestamps to them. You can't see my screen aside from this page. You're not trying to see my screen. I'm putting the link in the chat that takes you to the videos. Yeah, I'm only sharing my OneNote screen right now. I'm not trying to share my YouTube screen. Yeah, exactly. So the video and the audio match up. Like it records the video, the audio. It even records the chat. But the videos will always be there. And if you have trouble finding it later, you can just message me privately, and I'll send you a link directly to it. Okay. Any other questions? And the next time I'll try to fix this latency thing. I know how to fix it, it's a little complicated to fix it. Today I'm just kind of testing it out until 9 o'clock to see, like things that I need to fix, like for example, the latency thing. See if there's a good way to communicate with everyone, submit problems, do things live. But I kind of want to just make it an open forum so y'all can come and go as you want, right? So like now you could go and do your homework if you want, and then come back to me if you have another question. But you don't really have to book anything. You can just come and go as you want. And then when you're not here, or if I don't have a student, I'll kind of just work. Like you'll be able to see my screen. I'll be working on things. Like a second ago, I was doing differential equations. So you can see my differential equation work up here. But sometimes you'll see me doing something that you might need. So you're more than welcome to just kind of chill and watch and stuff like that. Because I need time to travel back home is the easy answer. I'm gonna stop at 9, but it takes me half an hour to get home. So. And I figured you could come in between 2 and 9. So you didn't really need the 9 o'clock class. Like you're getting time right now, right? And you're not even paying for it. I figured you would like that anyway. Like get your questions answered, do an earlier class, and it's free. So I would think that you would be saying, thank you for canceling my class, because now I don't have to pay for it. No, I don't do everything at home. But yeah, I'll probably do this again. I might do this every Sunday so that y'all can come in and out as you want and get whatever help you want. All right, let me take a look. All right, so I see this other question. Let me download it. And I'll put it in. Alright, let's go here. I'm gonna make it bigger. Alright, so let's see what this says. Alright, so it says a block on a horizontal surface is attached to a horizontal spring of negligible mass, as shown in figure 1. The other end of the spring is attached to a wall, and there is negligible friction between the block and the horizontal surface. A group of students wants to investigate how stretching the spring within the block spring system influences the motion of the system. For each trial of an experiment, the spring is stretched a variable distance delta x from its natural spring length, as shown in figure 2, and blocks of different mass may be used. The block is then released from rest, and the system is allowed to oscillate. Figure 3 shows the horizontal position of the block as a function of time for one trial of the experiment. The students must conduct an experiment to determine the magnitude of the force exerted on the block when the block is at position of a over 2, where a is the amplitude of oscillation for the block spring system. For each trial, the students attach blocks of different masses. They stretch the spring, release the spring from rest, measure the period of oscillation, and then measure the maximum velocity v of the system. How should students use a graph to determine the magnitude of the force under consideration? So you're looking for the force of the spring. Okay, so force of the spring is usually negative kx. The problem is that you don't know k. You know the distance that they're traveling. They're pulling the spring a distance of a over 2. So we could say that this is negative k times a over 2. But like I said, we're missing k. We don't know what k is. But you can solve for k. You know the period formula, right? I kept writing it down a second ago. As a matter of fact, we found the k formula, right? The k formula is right here in terms of the spring for a period. So I'm actually just going to recopy that formula. So it's k equals 4 pi squared m over period squared. So let's write that down instead. So k is equal to 4 pi squared m over the period squared. So it's kind of nice that I found that earlier. Yeah, the terminology is kind of weird. But I can tell you right now, like at the beginning of the problem, when they say things like friction is negligible, mass is negligible, they're really just telling you don't overcomplicate the problem. Okay, so I kind of just ignore it. Like I know they're not going to overcomplicate it. So what I can do now is plug this in for k. So I have negative 4 pi squared m over the period squared, and it's still times the amplitude over 2. Right. So essentially, to summarize, all I did was plug in an expression for k, which was actually the expression we used earlier for the period, and I plugged in x, which is a over 2. And so now I'm looking for some kind of answer choice that talks about multiplying by a over 2, and then something to do with the period squared, because that appears to be involved in it. So if I look at the answer choices, first one says graph the velocity as a function of 1 over m. Well, in my formula that I have right now, there's no velocity, so it doesn't depend on velocity, so that's wrong. B says determine the magnitude of the slope of best fit of velocity squared. Once again, if you look at the formula that we have, it doesn't depend on velocity, so we can get rid of that also. C says determine the magnitude of the slope of the line of best fit of the period squared. There we go. Right, so we have the period squared. D says determine the magnitude of the slope of line of best fit of the period. That's wrong. It should be the period squared, not the period. Right, so it's C. Right, you're kind of looking for a formula that just has like the relationships from the final equation that you have here. Any questions on what I did here? Could you re-explain what you said for eliminating the last two answer choices? So for eliminating D, D says we are looking at the period, but that's wrong. It should be the period squared. And then for B, it says the velocity squared, but that's also wrong, right? Look back at this equation, right? The equation that we found depends on the period squared. So B is wrong because it says the velocity squared. D is wrong because it only says the period. It should be the period squared. Right? The formula that we found depends on the period squared. C is the only one that says period squared. Right? It says it right there. Kind of hard to see, but it says period squared. That's the right relationship. Does that make sense now? Cool. All right, let me take a look at your other one that you submitted. Let's see. So the other one looks like the same situation, but now they're asking for potential energy of the spring, maybe. So let me import that picture in. Then I'll make it bigger so we can see it. There we go. All right, so this one says, in one experiment, the students allow the block to oscillate after stretching the spring a distance a. If the potential energy stored in the spring is U sub s, then what is the change in kinetic energy of the block after it is released from rest and has traveled a distance of a over 2? So normally, the potential energy of a spring is 1/2 k times the distance traveled squared. But since they pulled it some distance a over 2, right, that means we got to pull that out. So let's plug in a over 2. So you have 1/2 k, but then they put a over 2 as the length that it was stretched. So that would give me a squared over 4. So I end up with 1/2 k a squared over 4. And so what I could do is technically just pull out the 1/4. So the 1/4 is way out front. And so what you have left is 1/2 k squared. But this would be the final potential energy of the spring. You need to find the initial potential energy of the spring. So initially it started where? It started off at a distance of a. Okay, so initially it started off at just a distance of a. So it would have been 1/2 ka squared initially. So you kind of want to like subtract these from each other because you want the change, right? Change is final minus initial. Okay. And you might get like a negative answer. That's okay. Just ignore the negative. Negative just tells you if energy was lost or gained, so you don't have to worry about that too much. So if I plug this in, it's 1/4. Right? Make sure you understand that this stuff in parentheses is the initial potential energy. So it's 1/4 the initial minus, and then this is just the initial potential energy. So you have 1/4 the initial potential minus the initial potential. So it's kind of like algebra, right? 1/4 minus 1 is -3/4 the initial potential. And remember, you can just ignore the negative. The negative is just telling you that you lost energy. So they probably just assume it's 3/4 of the initial potential. So try to break it down into what I did one step at a time. I plugged in x, which is a over 2, right? Pulled out the 1/4 that kind of got produced. Then I understood that the initial potential was just 1/2 Ka squared, so just call that initial potential. And so you're doing 1/4 the initial minus the initial, which is -3/4 of the initial, and we drop the negative because we know that we're losing energy. So we don't really care if we're losing or gaining. Any questions on what I did? Yeah, the last sentence was just, I was just kind of summarizing the process. I plugged in a over 2 for x. It produced a squared over 4. I pulled out the factor of 1/4. So I'm left with 1/4 the initial potential. Then I started with some amount of initial potential. And I just subtract those. So 1/4 the initial is what I end with, minus the initial potential that I started with. 1/4 minus 1 is -3/4. But we can drop the negative because the negative just implies that we lost energy. Right? Negatives are meant to be interpreted. You don't really use them. Unless the answer choice had an obvious negative in it, but they don't. Any other questions on this one? Cool. Vedant, I'm going to take a quick few minute break. I will be back in about 10 minutes. So if you want to leave and then come back later, you're welcome to. If you want to submit any more questions, you can do that as well. I'll come back and start again with any questions that I see there. If you're not here when I do those questions, it's okay. You can always rewatch the video and I can timestamp it so that you know where your question is located. And you'll be able to see the timestamp. Like it'll just say, physics question or something. But I do have to take a quick break because I've been on here for a while. So I'll be back in about 10 minutes. Okay. So the live will stay on, but I won't be here for a few minutes. So I'll be back in a bit.
song. Or milk. That doesn't even last 30 days. So that's why at CarMax, we created the Love Your Car Guarantee. Because sometimes it takes a full month to realize the car you picked is really, for sure, 100% definitely the one. Or get your money back. It's car buying reimagined. CarMax. 30-day, 1,500-mile limit. See CarMax.com for details.
Hey Katie, I didn't see you join. Can you hear me okay? Great. Just giving you a heads up, there's like a little bit of a delay between the video and like the chat message. It's something I'm trying to fix, but I'll probably have to fix it for next time. I know how to fix it now, but it's a little too late to change it. To answer your question, where am I pulling this question from? It's coming from a differential equation textbook. So it's a bunch of just separable differential equations. Yeah, you can still type. I'm just letting you know that there's like a delay between like my video and the chat. I think it's about 15 seconds. So if you see me reply verbally, right, it might take a second for the chat to kind of catch up. But I'll be sure to fix that for next time. Yes, if you want to see the original problems that I'm doing, I can kind of import a little picture. Maybe that'll help. These are kind of just nice differential equation problems. So here's like a big collection of them. So what I'll do is I'll import like a picture, and then you can see like a few of them that I plan on doing. This one's kind of just the first one. So this is a few of them that I'm going to do. But you can also submit a question if you have one, and I'll do it through the YouTube live thing. But that's up to you. So I was just going to kind of keep going on this problem. If you want to follow along, you can. It'll kind of just sound like I'm talking to myself, though. So all I'm doing right now is just separation of variable to get y on one side and t's on the other. And so now for the left side, I have to do u substitution. So I'll let u equal negative y plus 5. So du would be negative dy. So dy would be equal to negative du. And so there's my little toolboxes. And so I kind of plug everything in. So I have negative du over u equals dt. And now I can integrate both sides. So integrate the left side and the right side. And so I kind of recognize the left side as ln. I can do the area problem. Yeah. Let me finish this one up and then I can do that one. So this is going to be negative ln absolute value of u equals t plus c. So from here, I can probably move the negative over to the other side. So I'll just multiply the whole thing by a negative. Yeah, I just want to make sure I finish this one. So it'd be ln absolute value of u equals negative t. I'll keep this as plus c for right now. And then change it back to a regular function, so change it to exponential form. So our u was negative y plus 5. But this would be e to the negative t plus c. And so probably here's the weird part. You can technically rewrite that right side as e to the negative t, sorry, times e to the c, right? Because when you multiply bases, you combine exponents. But then recognize that e is a constant, c is a constant. So a constant raised to a constant can be simplified further. It's really just a constant. So it's very common for us to just write this as a big constant out front. So we can just rewrite that as just a plain constant in the front. So now if I'm solving for y, I can multiply this entire thing by a negative and get y minus 5 equals negative the constant e to the negative t. And then we just add the 5 over to the other side. So the 5's will go away. So I have y equals negative c e to the negative t, and then plus 5. So I just wanted to do this one and to have like a good example of the e to the c thing, like how that becomes an additional constant out front. And so we can just write it as a capital C in the very front. But yeah, if you want to see the area problem, but didn't we complete the area problem last time? So do you want like a different area problem?
A lot can change in 30 days, like the weather, or your relationship status, or your favorite song, or milk. That doesn't even last 30 days. So that's why at CarMax, we created the Love Your Car Guarantee. Because sometimes it takes a full month to realize the car you picked is really, for sure, 100% definitely the one. Or get your money back. It's car buying reimagined. CarMax. 30-day, 15-month
Right, so we
financing.
did one,
See
but
CarMax.com for details.
you're not sure how to completely understand how to do it still. I feel like you understood it. I think maybe you're just doubting yourself. But why don't you try doing one on your own? I can make a recommendation from like a past FRQ. Give me 1 second to find one for you. And I would just say maybe try it, see if you can do, some of it, or go as far as you can. So I'm going to put the link for the 2018 FRQ. I'll put it in the chat for you. So open that one up whenever you have a second, and try doing problem number 3 is pretty similar. Is problem number 3 what you're talking about with area? Where they give you a graph? Let me know if that's the kind of problem you're talking about. What kind of problem are you talking about? Because that's the only area type problem that we did. We didn't do a different area problem from the FRQs anyway. Oh, from the multiple choice? I don't remember doing an area problem in the multiple choice. Was it like an integral question to find the area under a curve? I probably pulled that from the textbook, if that's what you're talking about. 23 of 1969. Let me pull that up real quick. So 1969, problem 23. One second while I find it. 23. Yeah, so that's area between, or like area under a curve, or area between curves. So you want to do another one like that. Yeah, so there should be a few in here. I'll find another one for you, 1 second. I'll just look at the 1973 one. There's always a couple in every test. I think we did number 15 as well from 1973. Didn't we do 15 from 1973? I feel like I remember doing that one. The e to the x over 2 problem. So I'll probably have to pull it from the next test. but I'll tell you which problem we'll do. 1985. All right, let's see. So I'm in the 1985 test right now. Yeah, so I found one. So 1985, problem 34. Yeah, let's do this one anyway. That's fine. I mean, we can always go back and do it later. So go to test 1985, problem 34. Make sure you're looking at the AB one. I can import it in too, if it helps. So I'll scroll down and just put it in here. There we go. Yeah, so I'll kind of just walk through this. And again, it'll kind of sound like I'm talking to myself, but you can kind of just follow along. So the area of the region in the first quadrant that is enclosed by the graphs y equals x cubed plus 8 and y equals x plus 8. So they tell you that you're in the first quadrant. That's important because if you're in the first quadrant, that means you're bounded by the line x equals 0. Let me do this in the right color. So you're bounded by x equals 0 and y equals 0. Right? Because that means you're kind of on the right side of those and above. But you're missing another x equation. So you need to find something that, shows you where these two graphs kind of intersect each other. So let's set these functions equal to each other real quick. So I'm going to set x cubed plus 8 equal to x plus 8. This way I can find out where the two graphs cross each other. So I can subtract 8 from both sides. Right, so all the 8's will go away. And so I have x cubed equals x. So it's officially just a polynomial. So I'd probably just subtract x from both sides. So the x's go away. So we have x cubed minus x equals 0. Now I can factor an x out. So I'm left with x squared minus 1 equals 0. And so I can kind of see three answers. I see x equals 0. I see x equals plus or minus 1. Now we probably don't care about the negative one because they said we're bounded in the first quadrant. And x equals 0, I kind of wrote that down anyway. But it looks like our graphs cross each other at x equals 1. So let's try to sketch a good graph of this so we can see what's happening. Remember, graphs are important. And I'm going to make the scale kind of big. So like 1, 2, and then let's make this like 1, 2, 3, 4. All right, so I'm going to kind of sketch this from 0 to 1. Let's see. I think this is going to go all the way up to 9. So I'm going to make the y-axis 2's, and I'll make the x-axis 1's. That way the scale fits and I can graph it nicely. So if I graph the first function, if I plug in 0, that's going to give me 8. So I'm up here. If I plug in 1, that's going to give me 9. So I'd be here. So here's x cubed plus 8. So it kind of looks like a little curve like this. Now I also need to graph y equals x plus 8. So y equals x plus 8 starts off at the same place. I'll do this one in purple. And then if I plug in 1, I also get 9, but it should be linear. So it should look like this, like it's just a line. All right, so the region you're looking for is that region inside the two graphs. Okay, so hopefully that makes sense. Right, in large, it would kind of look like this. Right, you're finding that area in between. So whenever you're trying to find the area between curves, it's always the upper curve minus the lower curve. So we're going to say that the area is equal to the integral from 0 to 1, right, left to right, The upper curve, though, is the linear curve. So that would be x plus 8
Introducing Venture
minus the lower curve, which is x cubed plus 8
Where next?
You earn 10x miles on hotels
with respect to x.
and 5x miles on flights booked through Capital One Travel.
Right, so again, it's always the upper curve minus the lower curve. So now what I can do is just distribute that negative in the middle. So the 8's are just going to cancel out. So it's going to be x minus x cubed dx from 0 to 1. Right, so the 8's just cancel, but you still have x minus x cubed. And now you just integrate it. So normal power rule. So I'm going to say add 1 to the power, that makes it a 1/2 x squared. Because you add 1 to the power, divide by the new power. Do it again, so this will be 1/4 x to the 4th. And we're still going from 0 to 1. So there is my integrated function. Now you just plug in the top bound. So that'd be 1/2 times 1 squared minus 1/4 times 1 to the 4th power. And I could plug in 0, but if I plug in 0, I'm just going to get 0. So technically it's like minus 0. And then we kind of just combine like terms. So 1/2 minus 1/4 basically. And that would be 3/4. Or sorry, 1/4, not 3/4. 1/4. And that's it. So just some notes for yourself on the side. So when you find the area between curves, so area between curves, right? Advice number 1, always graph the functions. Number 2, check for points of intersection, like where do the graphs cross each other? So points of intersection. And then it's always the upper curve minus the lower curve when you put it in your integral. And then everything after that's pretty mechanical. Just integrate the function, right? Plug in your bounds, do your thing. Any questions on how I did this or how I got the answer? Cool. The process is pretty simple. It's pretty straightforward. If there's any weird situations, you'll usually see it when you graph it. Sometimes graphs will cross each other and stuff. Yeah, of course. And then it's really just how comfortable are you at, integrating those functions. This one was kind of nice because it's just a power rule, so it wasn't that bad. Do you want me to assign one for you to try to do? Doing the graphing part? Yeah, you just kind of have to take your time on it. Like plug in values, take your time. Don't rush the graphing part, it's pretty important. Yeah, let me assign one. So let's try going to the 1987 exam. Give me 1 second to kind of get, or 1988 exam, sorry. Let me get there and find one that does this. So number 21, again, I can kind of import the picture if it helps. Number 21 from 1988. So here's the problem. I'll make it a little bigger so you can see it. There we go. So they say find the area of the region enclosed by the graphs y equals x and y equals x squared minus 3x plus 3. So I would recommend finding the points of intersection first, right? Find out where these graphs kind of crisscross or whatever, because they kind of form natural boundaries and enclosures of the area that you're looking for. And then generate a good graph based around those points of intersection. And then set up your integral, identify the upper function and lower functions so that you subtract them correctly. So I'll give you a minute. Try to do this on your own. If you get stuck, just let me know, and I'll kind of start working on it myself. And if you get the answer, you can just let me know, and I can tell you if your answer is right. And I guess you found out, but the original link for the YouTube live, the delay was a lot bigger there, so I had to make a new YouTube live. But I figured if people went to the channel, they would see that there's a new live and just click on that one. So it looks like you found it. But oh, before I forget, can you please subscribe to the channel and turn on notifications so that if I do this again, it should automatically notify you that I started a live. That way you know when when I'm doing one of these. And if I have to create a new live, it should automatically tell you. That way you don't have to go looking for the link or anything. But I'm kind of telling all my students just click on subscribe or something to get notifications. Cool, thank you. Yeah, that's fine. How are we doing so far? Are we stuck on anything, or are we doing okay? Just trying to figure out if I should start on the problem now, or if you're still working on it. So we're having trouble with the graphing. That's fine. So just kind of look at how I graph it. But don't think calculus when you're graphing, right? Think like algebra 1. You know what y equals x looks like. You know what y equals x squared minus 3x plus 3 looks like, right? It's a line and a parabola. So all you have to do is just graph the line, graph the parabola, find out where they cross each other. So I'm going to start by finding points of intersection, right? Because I said that was probably one of my suggestions, points of intersection. That way you're not just graphing blindly, but you kind of have like a purpose of what you're trying to graph. So set the two functions equal to each other to find those points of intersection. So there's me setting them equal. Now we got to get everything on the same side to solve this quadratic. So I'd probably just subtract x from both sides to get the x's on the same side. This way the x's go away. So then we'll have x squared minus 4x plus 3 equals 0. Okay, so there's our quadratic. And you just solve this, whichever way you want to. You can factor it, quadratic formula, whatever is comfortable. I'm going to factor it. I know this factors into x minus 3 and x minus 1. So I get two solutions, x equals 3 and x equals 1. Right, so that literally means like you're going to get a line with a parabola, and it's going to hit right here at x equals 1 and right here at x equals 3. Right, so now you kind of know like where you need to graph it. So let's do that kind of nice and clean. So let's make a graph. But I just got to go from 1 to 3. So let's do 1, 2, 3. And then just try to anticipate, what your y values will be. If I plug in 1 into the quadratic, let's see, 1 minus 3 is negative 2. Negative 2 plus 3 is 1. If I plug in 2, I'll go ahead and plot the points. Sometimes I just try to anticipate my y values so I know my scales. So when I plugged in 1, I got 1. Then I try plugging in 2. So 2 squared is 4. 4 minus 6 is negative 2. Negative 2 plus 3 is also 1. And then if I plug in 3, that would be 9. Minus 9 is 0. But then plus 3 gives me 3. So it's like here. So it probably has some kind of vertex like in the middle. So it's probably something like this. Scale's a little funny. And then if I graph the line y equals x, it would just be 1, 1, 2, 2. I'll graph it in purple. And then 3, 3. Right, so it's a line right there. So there's my line. Okay, so now you can see your graph. So this purple graph is just y equals x. And then the blue graph is y equals x squared minus 3x plus 3. Right? But setting them equal to each other to find the points of intersection helps you figure out like where to graph. Right? So I knew I was kind of graphing from 1 to 3. Any questions on how I got that graph? And I'll go ahead and mark the area that we're looking for, which is this area here. Cool. Yeah, so see if you can find the area now. So integrate, make sure you notice that your upper function here is the linear function, so x, and then minus the lower function, which is the entire quadratic, and you're going from 1 to 3. Like I said, if you get an answer, just let me know. And I'll tell you if you're right or wrong. Just checking to see how we're doing. If we got an answer yet or if we're still working. Yeah, so it sounds like maybe you messed up somewhere. I can tell you where most people mess up. Most people mess up on the subtraction, is they forget to distribute the negative. Yeah, so let me try to keep going, and then you can see if you catch your error. So I'm going to say the area is equal to the integral from 1 to 3. And remember, it's your upper function, which in this case is x, minus your lower function, which is x squared, minus 3x plus, or minus 3, or plus 3, sorry, plus 3, with respect to x. Right, so most people will forget to distribute that negative in the middle, and so it messes up your numbers. So I have the integral now from 1 to 3 of x minus x squared plus 3x minus 3 dx. So check and see if you made sure that you distributed that negative. Now if I combine like terms, I can combine those x's. So integral from 1 to 3 would be negative x squared plus 4x minus 3 dx. And now we can integrate. So we add 1 to the powers, divide by the new powers. So it's negative 1/3 x cubed plus 2x squared minus 3x. Right, there's our function. Okay, and then we're just going from 1 to 3. So 1 to 3. And so now we can plug in that upper bound. So it's going to be negative 1/3 and then 3 cubed plus 2 times 3 squared minus 3 times 3. Right, now I like to put this in brackets because this is where I plugged in the 3. Right, and again, you're supposed to subtract the lower bound, so I put this in brackets. This is another place where you have that negative in the middle, so the negative technically distributes, and so a lot of students kind of forget to distribute it. So now I'm going to plug in the 1. So it'll be negative 1/3 times 1 cubed plus 2 times 1 squared minus 3 times 1. And then I just simplify as much as I can. You know, however much comfortable you are at simplifying this mentally. So 3 cubed is 27. 27 divided by 3 is 9. So I get negative 9 plus 18 minus 9. And I don't do too much. And then over here, I'm going to have negative 1/3. Fix my parentheses and negative 1/3. And then plus 2 minus 3. And then negative 9 minus 9 is negative 18. Negative 18 plus 18 is 0. So you actually just get a 0 here. Minus, and then this is negative 1/3. 2 minus 3 is negative 1. Okay. And so negative 1/3 minus 1 is negative 4/3, but then times the negative in front gives me a positive 4/3. So it gives me 4/3, and that's the right answer. Right, so if you notice, there's a lot of negatives, right? There's a negative in the middle, there's negative when you subtract, and you distribute negatives and stuff like that. So most of the time, the mistakes with integration are negatives. People just kind of lose them or forget them or something small. And so it messes up your final number. Any questions on what I did? Multiplied by a positive 1/3. Okay. Yeah, it's always something instead of a negative. Yeah, usually it's going to be an error with a negative because negatives are just so easily dropped. Right? That's why you want to slow down and like look up and then bring symbols downward, like down your page. Right? So every time I do this, I'm kind of like negative 1/3. Right? My eyes go like this, and then bring down the 1/3, and then my eyes go like this, and I see the negative the whole time I'm doing this. So I kind of get out of my head, and I just look at what I see on paper, and I just move stuff down. And every time I kind of get caught up in my head, that's where I'll make a mistake. But it's very visual. But if you got the right setup and everything, then that means you understand it. Like you know what you're doing. You probably just need to do more practice to get comfortable with it. Okay. And you'll always see like exactly one of these on every MCQ. So, and they're always kind of in the middle, like somewhere between 16 and 25. So if you look through the MCQ exams that were released, just look in the middle of each test, you'll find one. It'll say find the area bounded by the curves. Or you can do the ones out of the book. Anything else that you think you had a question with? I'm actually gonna have to stop at 8:45 today, because I have a little bit of a walk back to my car before I go home. But yeah, was there anything else that you want to talk about? Hey Prathana, I sent you questions via the Google form. Look at those ones Katie's done. Yeah, that's fine. I think I saw them. I was just kind of waiting for people to enter the Zoom. I know some people had trouble finding it. Prathana, since you're here, make sure you like subscribe to the channel and turn on notifications so that if I have to make a new YouTube live like I had to do today, it'll actually notify you that I did that. And then you don't have to get the new link and stuff like that. So just hit the subscribe and then hit the notification icon. Sure thing, Katie. If you have anything else, I might do this again. Right now you know how it works. You just come in, ask a couple quick questions and then leave. That's pretty much it. It's pretty simple. Parthon, I'm gonna go ahead and take a look at what you submitted. Let's see. Oh yeah, I did this with Miriam, I think, a little while ago. So let's see. So Kate, if you click on the channel, you should see like videos. And if you look under the list of videos, all the videos will be there, including past lives. If you don't have the link for it, I can give you the link for it. Give me 1 second to kind of do that. But normally just go to a channel and then click on videos. So here's the link to the channel. I'll put the link in the chat for everyone. All right, so there's the channel. So if you go to the channel, in the middle you'll see a tab that says videos. Just click on videos. And then you'll see a list. It'll say like live, homework, help. Those are the past lives. So you'll see like one said it was like 3 hours and 53 minutes long. What I'll do is I'll go back in there and I will, you can't find the old one. I mean, I can give you the link straight to the videos. So here we go. So there's the link straight to the videos. Yeah, the old one is the one that's 3 hours and 53 minutes long. That's the old one. And then I had to restart it, and I think it was like 32 seconds long, which I'll delete. And then the current one. The current one won't show up until I'm done. Okay, but it's that first one that says 3 hours and 53 minutes. Hopefully you see it there. But what I was saying is I'll go in there later and I'll like put timestamps on it so that if I answered a question, you'll see a timestamp and it'll tell you. It's not there. It's there for me. You might need to refresh your screen or something. I can link you directly to the video. 1 second. If that helps. There you go. That's the link directly to the video. Yeah, I'm not sure why it's not showing up for you. It shows up for me. Can you click that link and see if it takes you straight to the old video? And just kind of let me know. And then Parthon, I'll go ahead and import that picture. of that one file. And then I'll start solving it. Oops. What? Let's download this. Huh. It's not letting me download it for some reason. Let me try. I didn't realize it was private. I didn't think it would be. I can try to fix that if that's a problem. Give me 1 second. Yeah, it doesn't say they're private. It says they're all public. Like, I'm looking at it and it says that it's all public. Yeah, it doesn't say it's private. It says it's public. Let me know what happens when you click on it to try to open the video. But I'll put the link in the chat again, just in case. Does it tell you that it's private? Because it doesn't say it's private for me. It just says public. I'm going to kind of confirm it just to be sure. You know what it might be? It might be that the file is pretty large. So it might take a second to show up. But yeah, it's working for me. Like I can play the video and everything. And I'm not even under like my administrator privileges. I'm just viewing it like a normal viewer. And it plays just fine for me. Yeah, it doesn't say it's private. I just double checked. It's public. Maybe try closing the tab and then open it back up and see if you can revisit it. Just maybe bookmark the link. But it should always be under videos. You'll see it there. Alright, Parthana, let me try to do this problem. For some reason, it's not letting me download the problem. So I'm just going to take a screenshot of it and import it in. There we go. Alright, so I think the problem is really just asking us to draw it. But in order to graph it, I need to find all this information. So let's start by finding the factored form. So if I factor the top, this would be f of x equals. So the top is just difference of two squares. So it should turn into x plus 6, x minus 6. And then if I factor the bottom, that's plus 4 minus 1. So plus 4 and minus 1. Right, so there's the factored form. And then I usually do this a little bit out of order. The first thing I find are the vertical asymptotes. Right, so to find vertical asymptotes, you take the denominators and you set those equal to 0. Right, so x minus 1 equals 0. So you should get x equals negative 4 and x equals 1. So there's your vertical asymptotes. And I'll put them in their little boxes. X equals 4 and x equals negative 1. And then I graph them. So I go to x equals 4 and I kind of draw little imaginary lines that I can't cross. And x equals 1. Oh, sorry, it was negative 4, wasn't it? Oops. Not 4. So I'll go ahead and graph 1 first. So here's 1. And then I'll graph negative 4, not positive 4. 2, 3, 4. So I'm over here. So I'm graphing my two vertical asymptotes. There we go. And the next thing I could do is I graph my horizontal asymptotes. So a lot of y'all kind of memorize a special rule. I think y'all do like bow, bow, bottom kind of thing. You can memorize whatever you want to memorize. I just memorize that if the powers are equal, I take the coefficients in front. So there's a coefficient of 1 here and a coefficient of 1 here. So I know I have a horizontal asymptote at y equals 1. Right, so that's the rules of horizontal asymptotes. So now I can graph my horizontal asymptote. I'll probably have to make a little tick mark here because your teacher didn't draw her ticks. 2, 3, 4, 5. So I have an asymptote at y equals 1. So here we go. And just straight across. Alright, so that's what I do first. Graph the horizontal and vertical asymptotes. Now the domain, you actually already found the domain. Okay, the domain is everything except the vertical asymptotes. So that means my domain is from negative infinity to negative 4, union negative 4 to 1, union 1 to 4. Now I know your teacher writes set builder, so here's what it would look like as set builder. I'll just kind of write it over here to the side. In set builder, you would say that it's all values of x such that x is not negative 4 or 1. Okay, I don't really care which one you use. Interval is a little more proper. Set builder, that's a teacher just trying to save some time. Okay, removable discontinuities, we don't have any. Okay, removable is when a factor will cancel on the top and the bottom. But there's no factor here that cancels on top and bottom, so you don't have one. Okay, so I'm just going to write none. In behavior, fun fact, in behavior is just another way of saying horizontal asymptotes. Right, so I already found my horizontal asymptote. It's at 1, which means my in behavior is also 1. They're the same. So this is 1, and this is 1. Okay, so it's kind of a nice trick. Just whatever your horizontal asymptotes are, that's pretty much your in behavior. Okay. So to find x-intercepts, you set the top equal to 0. So I would set x plus 6 and x minus 6 equal to 0. And that gives me two answers. X equals negative 6 and x equals 6. So there's your x-intercepts. So x-intercepts, I'm going to put negative 6 comma 0 and 6 comma 0. Okay. Now I know some teachers will write like x equals 6 and x equals negative 6. That's a little improper. Okay, an intercept, you're supposed to write it like a point. If you write x equals 6 or x equals negative 6, what you're actually writing down are the roots. Right, and the roots and x-intercepts, not quite the same terminology. Okay. So if she had said write the roots, then you would say x equals negative 6 and x equals 6. And so what I usually do is I graph those. 6. So here's x equals negative 6, and here's x equals positive 6. 1, 2, 3, 4, 5, 6. So I can start by graphing those. Then we need the y-intercept. Y-intercept's pretty easy. You just plug in 0 for x. So it'd be f of 0. So that'd be 0 plus 6 and 0 minus 6 over 0 plus 4 and 0 minus 1. And then you kind of just simplify that. So I would get negative 36 on top over negative 4 on the bottom. And that would give me positive 9. Right, so it's kind of high up there. Let's see if there's a good way to do this. What if I make these 2's? Then I kind of have to change my horizontal really quick. Sometimes the scales for these are kind of gross. Let's make my y-axis. Oh, let's actually make our y-axis 3's. That way it works out really nicely. So my y-intercept is at 9, so it's right there. Then I have to kind of put in my horizontal again. There we go. Just kind of remember that the horizontal is at 1. Cool. This way it'll fit. So you can kind of anticipate what the graph's going to look like on the right side. It's got to go through your point and then approach those asymptotes. So it's going to do something like this, and then probably get like really small, and then then it's going to get really close to that vertical asymptote. So something like that. Okay. And then on the far left side, same thing. It's going to get close to your horizontal, and then it's going to get really close to this vertical. And there's the left side of the graph. Now the last thing you need is the graph in the middle. To get the graph in the middle, you probably need more points. So my final suggestion is to make a table of x and y. And then once you make this table, you're all done. All right, just try a few points. I would probably try maybe -3, -2, -1. Right, you plug those into the function and kind of see what you get. So let's see, if I plug in -3, -3 plus 6 is 3, -3 minus 6 is -9, and then divided by -3 plus 4 is 1, -3 minus 1 is -4. So this would give me like 6.75-ish. So it's kind of a big number. So -3 is like 6.75, so 6.75 would be right there-ish. Then you can try -2. So -2 plus 6 is 4, times -2 minus 6 is -32, divided by -2 plus 4 is 2, times -2 minus 1 is -3. So it's like 5.3-ish. So -2, 3, 4, 5, so probably right here somewhere. And that's probably good enough. I can kind of tell what's happening. So it's going to get close to this vertical, come down somewhere, come back up, and then get really close to this vertical. And a lot of times when you have two asymptotes like that in the middle, you'll make a parabola. It just usually looks kind of like a slanted parabola a little bit. And that's it. That's the graph. Oh, I didn't write down my y-intercepts. So my y-intercept was at 0,9. So that's everything. Any questions on how I did this problem? And by the way, there's a little bit of a delay in the audio. I think it's like 15 seconds. But I'll fix that for next time, so we don't have that problem. And just to let you know, I do have to stop, because I have to actually walk to my car. Okay, that's what I was doing before, so I guess I will just continue to do that. I also have another question, which I sent you on the Google form. That's the other day. Yeah, so unfortunately I have to stop, but what I can do is just do that as a study log for you, and I'll just send that to you later this evening when I get home. I have to stop a little early because it takes me a while to get in my car so that I can go home, because I'm not at home right now. So I'll have to stop here, but remember, you'll be able to rewatch this video whenever you want to. Also, kind of let me know privately if you're not able to access the video as well, because I think Katie says she couldn't find it. If you can't find the video, then I'll try to figure out what's wrong with it. For next time, I'll make sure I fix the delay issue so that we don't have this problem again. But I'll probably try to do this again next weekend. Okay, it seemed to go pretty well today. But I'll go ahead and stop here, and I'll do your final question as a study log for tonight. Okay, so just look for it later when I get home. So go ahead and stop here, and I just see y'all next time.